Welcome to Beyond Buzz. Humanity has always looked up at the stars, wondering if we're alone. Now, we have a new tool in our cosmic quest, the James Webb Space Telescope, or JWST. This isn't just another telescope, it's a time machine, a portal to worlds we've only dreamed of. Launched in 2021, JWST traveled 1 million miles to its post at the second Lagrange point, shielded from the sun's glare. There, it peers into the infrared, seeing through cosmic dust clouds that blocked Hubble's view. It can witness the birth of stars and galaxies, and see the first light that ignited the universe. JWST lets us study the atmospheres of exoplanets, planets orbiting other stars. By analyzing starlight passing through their skies, we can decipher their chemical makeup. We're searching for water, methane, carbon dioxide, the building blocks of life. For centuries, our view of the cosmos was like peeking through a keyhole. Hubble opened the door wider. JWST has thrown it wide open. Now we can step through, explore, and read the stories written in starlight. This is a revolutionary leap, transforming our understanding of the universe. The age of cosmic discovery is truly upon us. With JWST, we're not just looking at the stars, we're beginning to understand our place among them. The universe is vast, and JWST is our guide. The journey has just begun. Among the stars, one system stands out. TRAPPIST-1e, just 40 light-years away. This tiny cool star hosts 7 rocky planets all about the size of Earth. It's a treasure trove for planet hunters, a compact system inviting us to ask, could any of these worlds be like ours? One planet, TRAPPIST-1e, orbits in the habitable zone, the Goldilocks region where liquid water might exist. TRAPPIST-1e receives about the same starlight as Earth, making it a prime candidate for habitability. Before JWST, we knew its size, mass, and orbit, but its atmosphere was a mystery. Previous telescopes tried to glimpse it, but results were inconclusive. Was it barren like Mars, toxic like Venus, or something else? That's why TRAPPIST-1e became one of JWST's first targets. If we were going to find signs of an atmosphere on a rocky exoplanet, this was the place. The scientific community held its breath, waiting for answers. The stage was set for a discovery that could change everything. TRAPPIST-1e, once a distant point of light, was about to step into the spotlight. The search for another Earth had a new focus. Then, the data arrived. On November 10, 2025, scientists announced a groundbreaking discovery. TRAPPIST-1e is not a barren rock. JWST confirmed it has a substantial atmosphere. Even more astonishing, the telescope detected water vapor, life's essential molecule, in its skies. The atmosphere isn't thin. It's thick, dense, and rich with clouds, shrouding the planet in perpetual mist. Imagine a world where light from a red sun filters through water clouds, casting a diffuse, reddish glow. This thick, water-rich atmosphere could regulate temperature and shield the surface from radiation. JWST also found methane and carbon dioxide, gases linked to geological and possibly biological processes. TRAPPIST-1e is dynamic, with complex atmospheric chemistry. We're no longer guessing. We're measuring the planet's conditions. The abstract idea of an exoplanet has become a tangible place, a rocky world, similar in size to Earth, with a thick misty sky. We can now imagine standing on its surface, feeling the moisture in the air. TRAPPIST-1e is no longer just a point of light, it's a world waiting to be explored. The dream of finding water on an Earth-like planet is now reality. The universe just got a little more familiar. This discovery defies expectations. Red dwarf stars like TRAPPIST-1 are known for violent flares, thought to strip away planetary atmospheres. Many believed TRAPPIST-1e would be an airless, barren rock, but JWST's findings turned that idea upside down. TRAPPIST-1e has held onto a thick, water-rich atmosphere, a game-changer for our understanding of habitability. It forces us to rethink what makes a planet livable, opening up countless other star systems as potential homes for life. Red dwarfs are the most common stars in our galaxy. If their planets can keep their atmospheres, the number of potentially habitable worlds skyrockets. TRAPPIST-1e is now a beacon of hope, a sign the universe may be more welcoming to life than we thought. The search for life just got a lot more interesting. How did JWST achieve this feat? It's a blend of size, location, and a technique called transmission spectroscopy. Its giant gold-coated mirror collects faint infrared light from distant worlds. When TRAPPIST-1e passes in front of its star, starlight filters through its atmosphere. JWST's instruments like NIR spec capture this light. Different molecules absorb specific wavelengths, leaving telltale gaps in the spectrum. By analyzing these gaps, scientists identify the atmosphere's makeup. Detecting these signals is incredibly delicate, like spotting the color of a fly's wings in a distant searchlight. JWST's stable position at L2 allows it to collect enough data for a clear signal. The result, a chemical fingerprint of the planet's sky. For TRAPPIST-1e, the spectrum showed deep valleys where water, methane, and carbon dioxide absorb light. This is direct evidence, a world revealed by its own starlight. Picture the control room as the first data from TRAPPIST-1e streamed in. Years of work led to this moment, the spectrum taking shape on the screen. A scientist points, "That's the water feature, it's huge." The dip in the spectrum was undeniable, water vapor clear as day. In that instant, theory became reality. TRAPPIST-1e was not a dry rock, it had water in its sky. The room erupted in cheers and quiet awe. JWST gathered this data in just 5 transits. What once took years, now done in days. We're living in an era of accelerated discovery. Light from TRAPPIST-1e traveled 40 light-years, carrying a secret message. It ended its journey at JWST's Golden Mirror, then to Earth, where we decoded its meaning. This is a profound connection. Discovery written in light. The universe just spoke, and we listened. TRAPPIST-1's discovery is more than a headline, it's a turning point. For the first time, we've confirmed a water-rich atmosphere on a rocky, Earth-sized planet in the habitable zone. The question is no longer, do such worlds exist, but what are they like? Water vapor, carbon dioxide, and methane together are tantalizing hints, biosignatures that point us forward. Next, JWST will search for even more specific signs of life, like ozone or chemical imbalances. This finding validates the focus on red dwarf stars, vastly increasing our targets. Future telescopes will be designed with this knowledge in mind. TRAPPIST-1e is now a roadmap for exploration. The ingredients for life may be common throughout the cosmos. The universe feels a little less empty. We haven't found life yet, but we found a world that could support it. Our place in the universe just got more interesting. The revelation from TRAPPIST-1e is just the beginning. JWST will now turn its gaze to the other TRAPPIST-1 planets, each a new mystery. Beyond this system, hundreds of exoplanets await their turn. We'll build a library of planetary atmospheres, deepening our understanding of what makes a world special. We are living through a revolution in cosmic discovery. For the first time, we can realistically search for signs of life on other worlds. The data is streaming in now. This is our era of exploration. JWST has opened a door that can never be closed. It's shown us a world with clouds and water, fueling our curiosity. The search for life is one of humanity's most unifying quests. With JWST as our guide, the future of discovery is brighter than ever. The cosmos awaits, and we are ready to explore.